discuss about how Qwen-VL-10 multimodal model work. So we can see this is the repository of official repository of Qwen-VL on Hugging Face. So it's a multimodal chat system for which is a visual multimodal version of large language model series. It is proposed by Alibaba Cloud, and it accepts image, text, and bounding box as inputs and outputs text and bounding box. To know about it, we can just move to this picture. We can see here it detects a woman and dog. So the thing this model is primarily does is when we see that the query here, like you give the model an image and you give the model a prompt like generate the caption in English with grounding. The grounding term means it will uh, uh, detect objects like where the actual things are. See, if it detects objects like dog and woman, it can uh, detect the positions of the objects in the image, and also generate a new image with the boxes. So this is the primary task of what it was built upon, but the additional tasks are like you can ask or go with chat system with the given input image. So there are few techniques we'll see. So as I mentioned, let's go deep into the architecture. So how it works. So it's a bit uh, difficult to say, but let's simplify it. So there are three stages mainly, and they follow each stage for each individual task. So when your input is like image text pairs, like image and prompt type that I previously shown in the image. So how it works is like at stage 1, the model is trained on image text pair using the vision transform model, or VIT we say in short, and a language model Qwen-LM with cross attention layers to align vision and language features. So here we can see a a learnable query embedding with the file, the input file, image file is feeded into the Qwen-LM model, and then the parameters are frozen in this part. So and then it is focused on the basic alignment of visual and textual information. On stage 2, it is for multitask and interleaved virtual VL data, and the stage 3 is the chat interleaved VL data. It's supervised fine-tuned model, and it's for multi chatting. So in our case, this is how the Qwen-LM model was trained to do multiple tasks. So let's deep dive into the main features. This is the pre-training info, how this model was trained, and this is the like overall performance. Here we can see the Qwen-VL did very well across multiple dimension of tasks, and it is nearly the state of the art performance across a diverse set of tasks. So let's deep dive how to use it. So we have to include the bits and bytes libraries. These are the necessary libraries. We have to import them, and we have to clone the Git repository, the original Git repository of Qwen. Then we have to clone the repository and move to the Qwen-VL, the internal repository. After that, we have to install the requirements. If I move back to the original repository here, you can see the GitHub. At GitHub, they have a file called requirement.txt. This file is like the uh, necessary libraries what you need to uh, include for your project to run, for this model to run, like transformers, tick token, and the versions are very specific. If the version doesn't match, then it's high chance that the model will not run successfully due to dependency conflict. So you have to follow that particular uh, required libraries must be installed. Okay, so now let's go. So after following these installing these requirements, then we have to uh, uh, we have to ensure at which platform are we running. So I have run it on TPU VM 3.8. It's a very high performance uh, processing unit. It is completely based on not GPU. It's completely based on CPU, and it's very powerful and very demanding for Kaggle. So it can also be run on GPU as well. They have mentioned it on the outer requirements here. We can see that the required are the GPU. You can see here where's the CUDA. Yeah, for GPU users, they have to use CUDA 11.4 version. Then they can yeah, these versions are come up with by default, like on Colab, on Kaggle, they are come up with by default, so it updates time to time. So if you have GPU, then it's good, and if you don't have GPU, then you can continue with the TPU of Kaggle. It's free for 20 hours a week. Okay, so I have run that on TPU. It's very fast for inference call, that's why. So after that, I loaded the datasets. The datasets, for that part we need a library, another library for dataset loading. Then the main part comes, like the goat dataset. It's in the Hugging phase already, so we can search and see this dataset as well. So here you can see this is the goat bench dataset, and it was splitted in 33.5K around. So we randomized, we'll not use all the datasets, but we'll import some of them. So hi, here we imported these datasets, and then after saving this image, like we showed the thing here, like image dot save. We saved we showed the image, and we saved the image on a temporary file. Then this is the index of image, like after importing the dataset, you can see the first image, index 1 is this. So you can so from here, that if you select an index, and it will retrieve that particular image from the dataset. So and that dataset is saved on a local file. I'll explain that later. Okay, then comes the model initialization part. So the Qwen-VL model initialization is this is the basic process of using a tokenizer and a model. And for using Hugging Face models, this is the basic template for how we can use. I'm interpreting line by line. So these are the necessary libraries for inputting for making the connection with our dataset and the transformer model. And the seed, the torch seed, it ensures the reproducibility across many runs, that so that your model gives the same output this across multiple runs. So there is no conflict, like your model is performing here in a way, and in some other run, if someone runs this same code again, and that is running in another way, so it will make a conflict. So this is to reduce that, to ensure that the reproducibility is authentic. Then comes the tokenizer part, the auto tokenizer and auto model for casual LM. This is these are used for to load the tokenizer and the model. And the device map, it's just enabling the auto selection. If your GPU is enabled, then it will select the GPU, and as we are using the TPU, so it will select the TPU for this part. And the BF16 is for accelerating the inference, like it will boost up your um, inference. So yeah, we can call the models very fast, and it will respond very fastly in that case. So that's how it happens. And then finally, the evaluation mode, it is used for evaluation, our model evaluation mode, so like ensuring optimal inference performance. Then the model generation config is like generation config uh, for the model inference is introduced. So we are using the Qwen-VL chat for this case. So after executing this part, it will load the shards. The shards are like the parts. The whole thing is divided into parts. If you see it here, the files, there are 10 PyTorch model files. So each one is shards. Like they will ask, like the whole program, the whole system is divided into 10 models, and these will import, this is load into the model one by one and merge them all together. So these are called shards. So these will load here, and after completing the 100%, and then it will automatically run on the backend. Then we have to just call it by the image and text, a prompt. So we need a list format, which is in the tokenizer, and we need to structure a query, and then the query will contain the image, uh, the saved image location, the image file actually in local repository. So here comes the our temp file. Why we the first place we saved the image in a local file for further processing, and we are calling that file here, calling the image file here, and we are passing our text file, like the text input prompt, from here, and the image and text is going to the model from here, like model.chat. We are tokenizer, we have defined our tokenizer here, this part, and then the query, we have defined our query here, query structure, and we don't want to include any history as this will be a one-time chat only. So that's the thing. And after that, when we call the model, it will generate two things: one, history, that because we don't want any history, and one is response, like what response we want. So we want to print only the response, not the history part. So here the model's response is added, as we uh, included that what is in this image. And so that this image is a cartoon image of a man with short black hair wearing a suit. The man is Archer, a character from animated series. That's it. So it will explain about the image it was given. So that's how it basically works. Now let's see how we can use it to the good dataset. So I introduced a term like batch processing, like classifying memes from here. So we're not going to do each one separately. We are going to do set a loop, and we are going to generate the response from a certain index part from here. So we can see that for that part we'll set the index, like we will start from, as we know that it has around 33,000 33.5k rows, that means 33.5k images to be exact. So we have randomly selected around 150 of them. I'll explain that in a later video. So later part, we have selected like from 27,010 index to 27,017, let's start with that part. And we are just passing the index same way, and same way to the model, and we are plotting displaying the image first. Then we are generating a query like the we are passing the image path as an image, and also the text, the prompt, like we are asking the model to classify that one of the below categories, like is it hateful or misogyny or offensive or sarcasm or harmful. We're giving it options, but it has to just select only one of these five categories. So then the same things inference, and we are going to save that response and show that here. So we don't want to save the previous image, because we don't want it to occupy our local storage, local memory. So that's why we are removing the file after our task is complete. So after each iteration, it displays the certain image, the certain memes, and then it shows the response from for the inputs, like classification response. It has labeled it as offensive. This is also offensive. You can see. These are the data and the responses from here. So that's how the Qwen-VL model works. And now I'm going to describe you how I selected the randomly 150 samples, selecting 150 random samples from this data set, and it will save that in a CSV file. So let's go to our CSV file. So as it will just save the image file names. So and the true level and predictor level, we have to find the true level randomly, like manually from the data set, which is provided in the here, the file version. So when you go to the Bench, they have a file version, and on Bench test file directory, you can see the five different types of memes classified in this in here, and they are all labeled 0 to 1. We will demonstrate the test.json, so we can have a clear understanding about the fact. So I'm going to just overview a short thing, the like how the data set was that labels were extracted from it. So it has for each binary class, it has it has a label, one for positive and zero for that class negative. Like for suppose I'm going to show you the hatefulness probably. So let's move on to the JSON file. So okay, so here you can see that it has the image name, that .png, and it has an image ID for that, what we the index, what we actually called for that, the image ID, image name, and the level 1 means it is, as this class is for hateful or not, so level 1 means yeah, this is hateful. So this is labeled as hateful. And if you wanna see that the not hateful type, then we can see from here, like how about this image ID. So it says the gas bill is too damn high, funny, offensive means offensive pictures are very forced, so it's not hateful, it is labeled as 0. So from that part, so we can I have manually extracted the by the randomly selected IDs about their true levels, and this is the predictor level from our generation site. So we merged that, we collected that from the mains here, our from here we have collected the responses, and we merged them in here together as true level, predictor level, and the image ID. And from here we will analyze the accuracy from the so we need to include the libraries here, then we will upload the files, the beam classification result file, and load the data into data frame and check if the data frame is properly loaded by index and as a beam serial. Then I'll check the info that we have the number of objects, and then this is the whole classification process. So it has true level and predicted level, so we'll take the true levels as y true and predicted levels as y predicted, and then we'll call the accuracy score function with these two parameters, and it will generate the overall accuracy for our model. And for F1 scores, we'll just pass the true levels and predicted levels, and we will check the true levels as unique, and as the class levels, it should be the true levels, the unique true levels only. So this is how we define the variables, and then we will print our accuracy scores, and based on that, and if the level is equal to true levels, it will only generate the accuracy, and if it's not, then it will generate that the prediction was false. So this is how we will generate the accuracy, our accuracy metrics for each class, individual class, like the sarcasm, harmfulness, offensiveness. So that's how the whole accuracy measurement is calculated. Thank you for watching.